Thank you, Daniel. Thank you, everybody. So, who am I? Let's start introducing myself. It's my first time at the Kamailio world. So, I'm Alex. I would define myself as a DevOps. I'm the owner of a Croatian-based company that does IT consulting. And I've been developing web applications for 15 years now. In the last year, I joined the LSIP startup. So I was basically overwhelmed with the SIP and Kamailio stuff. Keep that as a disclaimer. So, OK. I'm very passionate about the lean startup methodology. I also love the Internet of Things, blockchain, and cryptocurrencies. And as you can see from the photo here, I'm an outdoor enthusiast, photographer, and alpinist. In this photo, I am on the Julian Alps in Italy. I really love the Montasio mountain range, so OK. OK, what I'll be talking to you today, it's the usage of the DevOps cross-functional mode of working with continuous integration and delivery in a complex multi-layer microservice infrastructure. Also, we'll be doing testing single routes in Kamailio on different layers of the architecture and do automation with Jenkins in a containerized environment. So at the end, we will also take a look at how to do test-driven development of single Kamailio routes. Let me cover just quickly some basic concepts that probably most of you know. So I did define myself as a DevOps, and we at our team, everyone tries to be a DevOps the best he can. So it's a practice that unifies development and operations, software operation, with a particular emphasis on quality assurance. Trying then to have shorter development cycles, increased deployment frequency, and have more deployable releases in close alignment with the business objectives, obviously. Also, in all of our DevOps chain, we try to do automation and monitoring of all the steps involved. So DevOps is, as I told you, is intended to be a cross-functional mode of working where we plan, create the software, verified package, release, configure, monitor, and then do it again. What do I mean with do it again? So we try to be as fast as possible to have ideas and features, enhancements, and bug fix deployed into production. And then from production, we monitor it and get feedback to have it evolve over time again and again. So the goals of DevOps is to have an improved deployment frequency, faster time to market, lower the failure rate of new releases, shorten the lead time between fixes, and also to be faster to recovery. Continuous integration is the practice of merging all developer working copies to a shared mainline several times a day. So we have developers just pushing a merging code to a same branch. And the main goal is to prevent different developers working on a different copy that after days, weeks, or even months becomes not possible to integrate with the work of the other developers. The delivery, which is sometimes confused with the deployment, is an approach in which the teams produce software in short cycles, ensuring that the software can be reliably released at any time, so we can deploy it whenever we want. We can also do continuous deployment if we want. So when the code is ready, it can go just immediately in production, or we can choose to do it when we want. So continuous delivery and DevOps have common goals and are often used in conjunction. And After the continuous integration and delivery stuff, obviously we cannot do it on a monolith. We can try it, but it's best to use a microservice infrastructure that structures an application as a collection of loosely coupled services that enable us to do the continuous delivery and deployment, even of large and complex applications. It also enables an organization to evolve its technology stack because every service can be written in a different language, can be used completely different technology because they are fine-grained and the protocols are just communicating between them with API normally. So we can experiment with different technologies on different services of our infrastructure. It also improves modularity and makes the application easier to understand, develop, and test, not only for the developers working at it, but also for new developers or even outsourcing our code to someone else. And what's the most important part, it enables continuous delivery and deployment. So let's take a look at our project infrastructure that you probably saw yesterday from Paolo's talk. We have a fully containerized environment, stateless Kamailio instances, multi-layer infrastructure, Kubernetes as a container orchestrator, and we also have custom APIs for SIF infrastructure orchestration because Kubernetes only orchestrates the pods. And we also have an external clustered DB which stores our data. So this is the infrastructure schema. We are running Kamailio on our edge proxy nodes. Also onto the root layer, we are trying to migrate from Asterisk and have everything done into the router layer. Asterisk is on the TPS layer, so it's doing only transcoding and playback service when needed. So our packets don't go every time to Asterisk. And then we have an API orchestration layer that just orchestrates everything and is the one that communicates the data to our data storage layer. And RTP engine is our media layer. So Kamailio in our proxy layer does the load balancing, obviously, when we also have call ID path maintained. And we have a first security layer where we check the user agent and use Pike. On the router layer, we do all sort of kind of things like user registration and management, session control, security intended as user authentication, IP filtering, billing, number normalization, end-to-end routing, RCR and carrier selection, failover, and rerouting. So how we do, we started doing the test on our infrastructure as we were doing it on a black box. So we were sending zip packets, simulating calls, and things like that, but we wanted to do more. We wanted to test just specific routes of Kamailio, and we wanted to do it even on the layer that's beneath the proxy just directly. So we end up with this configuration. So we are defining into the testing environment the inclusion of a Kamailio test CFG file that has our testing routes that we will see in a moment. And then into the request route, we just check if the header xavuzip test is set, and then we run these testing routes. So in our infrastructure, in order to test the router, because it's not available to the client outside, we had to introduce another pod, another Docker container inside our infrastructure that's on the same network of the proxy and the router, so we can send ZipP packets to that layer, to those Kamailio nodes. So we use CP as the majority of you probably. It's a free open source test tool traffic generator for the SIP protocol. It establishes and releases multiple calls, and it can have custom XML scenario files describing call flows, even complex flows, and dynamic display statistic, which is handy if you're doing manually. And you can have also periodic CSV statistic dumps. So this is an example of a test we are doing. The test is called test is scanner. We are also setting into the header the user agent SIPVicious. And we are expecting a response of 222 from our node in order to have this test checked as passed. So the root test is scanner that we include only in the testing environment is something like this. It just calls the root is scanner. And if that returns true, we are sending the reply 222. Otherwise, we are sending the reply 500. The root is scanner, and that probably you have already seen or you have implemented in your Kamailio nodes. It's something like this. Just check that the user agent is inside the scanner blacklist constant. If it is, like in this case, SIPVicious, it will return true. So our test will pass and CP will have a true response. So we are doing dynamic dispatching of our nodes. What does it mean? When a Kamailio comes up, it's completely stateless. So it tries to fetch the dispatcher list from an API. And in the early stages, we used this logic on Kamailio. Now we migrated it to API, but it's a good example. So the root should dispatcher reload will just answer 3 simple questions. And this is if are the dispatchers already reloaded? So is everything OK? Am I reloading the dispatchers right now? Or does it take too long to reload the dispatchers? So the root was something like this. We use the shared table dispatcher. And for the key list, we will set 1 once the dispatchers were correctly reloaded. So this one will return false because everything is fine. Otherwise, in the process of reloading the dispatchers, because we are waiting for the API and things like that, we will set into the list variable of the shared table dispatcher a timestamp. If it's older than 60 seconds, we will return true. So the dispatcher should try to reload again. So how could we test this root, Kamailio? We can have like a multi-stage test. And so we set the variable number of tests passed equals to 0, and the test we expect to pass. Then we just modify the shared table here and set the dispatcher list to 1. So the root should dispatcher reload, we return false. Negating it, we just increment the number of tests passed. Then we do it again. We reset the shared table to the timestamp. And obviously, the should dispatcher reload will return false. And we modify it again, putting a value older than 60 seconds. So the root should dispatcher reload will return false. At the end of this route, we just compare the number of tests we are expecting to be passed and the number of tests passed. So we will return 200. That's what SIP-P is expecting. Otherwise, 500. So we can, you see, we can test Kamailio roots and modify some variables, shared tables, whatever we want. And with SIP-P, expect a value and test Kamailio roots in this way. And then we obviously wanted to have a continuous integration and to automate those tests. So we used Jenkins. That's an open source automation server written in Java. It helps us to automate the non-human part of the software development, even if we can execute our specific tests manually. It does continuous integration and facilitates the technical aspects of continuous delivery. So our workflow is something like this. We have two main branches. Well, we use the testing branch to commit our daily modification to the code. If we have an issue that might take longer, we create a branch issue and merge it into testing. Jenkins is listening on the testing branch for changes, and then automates, so brings up all the environment because we have it full Dockerized. So brings up a full environment, adds the containers needed to do the tests, and modifies some variables, includes the Kamailio testing routes, and launches the CPP to do the tests, and also these routes test. If everything is fine and good, we are ready to go. Jenkins automatically merge that in staging. So in staging, we always have stable release. So in order to use CPP in Jenkins, we created some simple bash scripts. In the example before, we call it the Kamailio proxy scanners. We load it scenario, and as you can see, we can target it on multiple nodes. So not only on the Jenkins node used for simulating our infrastructure, but also on like a local node of the developer. And we target the proxy layer. So CPP is executed, and we are returning the exit code of CPP in order to Jenkins interpret it and do what he needs to do. So we have like a stage in Jenkins that it has the ability to have a list of all our pods in Kubernetes and to enter a defined pod and to execute the bash script that you just saw. Excuse me. So now after all of this, how can we do test-driven development and what test-driven development is? Test-driven development is related to the test-first programming concepts of extreme programming, and it relies on the repetition of a very short development cycle. So as you can see here on the right, the requirements are turned into very specific test cases. Then the software is improved to pass only the new tests. As Ken Beck said, the test-driven development encourages simple designs and inspires confidence. So that's what we want to do. And here's an example of test-driven development from before. So before writing the root is scanner, we will write this test that we will trigger with CPP. And we do like as before. So we have an if root is scanner and return our 222 reply that CPP is expecting. Once we have that, Kamailio will probably crash because we don't have the root is scanner. So this is an example of the XML from before. So we trigger test is scanner. And we write a simple is scanner root that just returns false. So now our test failed, but Kamailio doesn't crash. And after that, we will improve this root to have like an if user agent is vicious, return true, otherwise return false. And then adding new tests and testing other user agent, other scanners, we will probably end up with a root like this. So we saw custom testing routes in Kamailio. I really love the presentation of Zipgate that is testing the Lua. We are doing KME on Python now, and probably we'll do testing on the Python code solely. But this is a good example for ones that don't want to do KME, don't want to write Python, and want just to test some custom routes in Kamailio. Also, we saw the automation with CPP scenarios and Jenkins for continuous integration and delivery, and the ability to do test-driven development and to get into that mindset. That's all. Thank you for your attention. Questions?
Questions? Anyone with questions about testing? Okay, so more or less a similar question as previously. How did help you to improve? Have you discovered any issue or helps your team to not make big mistakes?
Well, it helps you obviously to test single routes. So if you're not sure, if you have more complex routes and you are not sure if that portion of the code is doing it correctly, and also for someone like me that is doing Kamailio only for not even a year, it's very handy. So yes.
I
Absolutely.
kind of missed a bit of your presentations. I'm not sure if your project, and Victor is not here, but there is this module CFGT, something like helping at the end of the execution to dump a lot of context information variables. Have you looked at that, or?
No,
Okay.
We haven't looked at that.
Then maybe as a suggestion, could be something
We are doing a lot of logging,
Okay.
so we are looking at the logs as something.
Yeah, as far as I know, from the moment when Victor made the pull request, it's dumping a large JSON with like what was executed, the variables, and so on. So that could be something that
Absolutely.
maybe you can integrate.
Okay.
Otherwise, thank you, Aleksandar.
Very simple. Okay.